Now dear student, we are going to discuss this question number 2.18, and in this question it is given to you, in a hydrogen atom the electron and proton are bound to have a distance of about 0.53 angstrom. Okay, we have to estimate potential energy of a system in electron volt, taking potential energy is 0 at infinity. Okay, fine. Actually we know we always define potential energy at a point whenever we are taking potential energy 0 at infinity. Clear? Our reference system is at infinity, and at infinity we assume potential energy 0. And actually we also know potential energy is maximum at infinity. Clear? Rather than if you are not decreasing a distance between two charges less than 10 to the power minus 15 meter. Clear? So important part is here we are taking reference at infinity where potential energy is 0. So whenever we are bringing two charges close to each other, at that time their potential energy decreases. Clear? It means we will get value in negative. Clear? So now in the first part it is given we have to find potential energy of a system in electron volt. Listen carefully. So how can we calculate? We can write like this, potential energy expression we know very well. This is K Q1 Q2 upon R. Clear? Now we know value of K. This is 9 into 10 to the power 9. Value of Q1 and Q2. Two charges are given to you, electron and proton. Electron is having negative charge and proton is having positive charge. So we can say this is minus 1.6 into 10 to the power minus 19, and it is also multiplied with 1.6 into 10 to the power minus 19. Clear? It is divided by distance between these two electron and proton is given to you 0.53 angstrom. Clear? So we can say 0.53 into 10 to the power minus 10. Clear? So now we can write like this, value of U, this is given by 9 into 1.6 into 1.6. Clear? And this will minus also. Clear? Now we have 10 to the power 9, this is 19, minus 19 minus 19, and we have this is 10 to the power minus 10. So we can say this becomes 10 to the power 19 plus, and this one is cancelled out. Clear? So we can say this is 10 to the power minus 19 divided by. Clear? Now we can say this value 0.53. But important part is here we will get answer in joule. Clear? But our objective in this question is to calculate value of potential energy in electron volt. So how can we calculate? We have to divide this term with 1.6 into 10 to the power minus 19. Clear? So this is 0.53 into 1.6 into 10 to the power minus 19, and it will be converted into electron volt. Clear? So we can say this one and this one is cancelled out. Clear? So now we can see, we can write like this, value of U, this is equal to minus 9 into 1.6 divided by, this is 0.53. Actually we can take 0.53 approximately 0.5. So we can say this is 1 by 2. So we can say this is minus 18 into 1.6 electron volt. Clear? So if it say 16 multiplies 6, I mean 18 multiplies 6, we can say we have 8, we have 4 left. Clear? So we have 18 multiplies 6, we can say this is 108. Yes or no? Yes, this is 108. So we can say this is 8. Now we can say 10 carry. Clear? So this is 27 or 27.8 electron volt. Yes or no? Yes or no? Or approximately, because we are taking here this is 0.50. Clear? So if we are taking 0.5, it means this value is 1 by 2, it will goes to the numerator, so this becomes 3.2. Yes. Yes or no? Listen carefully what I am saying to you. Listen carefully. Again I am repeating. Value we have minus 9 into 1.6, and this is 0.5. We can write like this, this is minus 18 into 1.6. Clear? So you can write like this, 18 multiply 16. Clear? So we can say this is what? 18 multiply 6 as equal. So you can write like this. This is what? 10. This is 5. We can say this is 8. Clear? So we can say 18 into 8, we have 6, and we can say 6, so 144. Clear? 144 divided by 5 we are getting, and this is for minus, we can say 2, we have 28 point, and we can see 8 electron volt. Yes or no? But actually here we have 0.53. Yes, so if you actually calculate, you will find this is equal to minus 27.2 electron volt. Yes or no? Here you will get minus 27.2 electron volt. Clear? So remember, here we are getting potential energy minus 27.2 electron volt. Clear to everyone? So I am writing here potential energy minus 27.2 electron volt. Clear? Actually, most important part for solving a question is what? This is not a calculation. This is the process by which we are going. Yes. Now if we talk about second part, what is minimum work required to free electron given that kinetic energy is half of the magnitude of potential energy. Actually we know kinetic energy is always positive, and it is given. This is half of potential energy magnitude, means we can say 27.2. So from here we can say this is 13.6 electron volt. Clear? So this is value of kinetic energy. Clear? Now actually our objective here is to calculate what is total amount of energy that we have to provide to this system, so that we can separate electron from this system. Clear? So now we can see total energy. Total energy we can say this is equal to kinetic energy plus potential energy. Clear? So value of kinetic energy. Value of kinetic energy is given by, now this is 13.6 and we have this is minus 27.2. So from here we can see, here we are getting minus 13.6 electron volt, this is total energy. Now we know at infinity total energy is what? 0. Yes. So if we want to free electron from a proton, or if we want to free electron from atom, then we can say we have to provide total amount of 13.6 electron volt energy. Yes or no? At that time we can say total energy becomes 0. Yes. So actually work that we are, the minimum work that we are providing here, this is equal to 13.6 electron volt. Clear? Actually we are getting here unit of work is also in terms of electron volt. Clear? So this is our answer. Now what are answer to A and B if 0 of potential energy is taken at 1.06 angstrom separation? It means in the previous situation we have we assume potential energy is 0 at infinity. Clear? But now we are assuming potential energy is 0 at a distance 1.06 angstrom. So now what we can do, actually now value of potential energy changes, because we always find potential energy difference. Clear? At infinity we are taking potential energy 0, but now potential energy will not be 0 at reference point. Clear? So how can we calculate potential energy? Actually here again we will write here formula, but formula will be A equal to potential energy, this is given by K Q1 Q2 1 upon R1 minus 1 upon R2. Clear to you? So value of K, this is given 9 into 10 to the power 9. Here we can say this is minus 1, 1.6 into 10 to the power minus 19 whole square. I have already put here value of Q1 and Q2. Clear? Then we can write like this, 1 upon R1. R1 we have, this is 0.53 angstrom, this is final position, minus, this is 1.06 angstrom, and we can say this is 1 upon 10 to the power minus 10. Clear? So now if we calculate, we can write like this, this is minus 9 into 1.6 whole square into 10 to the power minus 19. I am writing like this, and we have 10 to the power minus 19 also. So 10 to the power minus 19 and this become 10 to the power minus 10, and this one cancelled out. Clear to you? Clear? Yes. Yes or no? So now we can write like this, and if we are taking here 1.06 as an LCM, we can say this is 2 minus 1. Clear? So now we can calculate value of potential energy that we are getting. I am writing here minus 9 into 1.6 into 1.6 into 10 to the power minus 19 divided by, we can say this is 1.06. Now this value we are getting in joule. Clear? Now we can convert this value in electron volt if we divide this value with 1.6 into 10 to the power minus 19. Clear to you? Yes. So now we can say, we can write like this, value of U, this is given by 9 into 1.6 into this 1.6 into 10 to the power minus 19 is cancelled out. So we can say, we can write like this, divided by 1.06, and this is in electron volt. Clear? So if you calculate, you can say 9 multiply 6, we can say 5, we have 14.4 divided by 1.06. Clear? So you will get this value minus 13.6 electron volt approximately. Clear? Now you can say we are getting potential energy minus 13.6 electron volt only. In the last situation we are getting minus 27.2 electron volt. So what we are actually information getting, in previous situation we are providing minus 13.6 electron volt energy to a system. At that time the separation between electron and proton increases from 0.53 angstrom to 1.06 angstrom. Clear to you? And rest 13.6 electron volt is utilized to move that electron at infinity. Yes or no? So now we can see here we are getting potential energy minus 13.6 electron volt. Clear? Now if I say to you, this is total, we can say this is potential energy. What is minimum amount of work is to be required if kinetic energy is half of magnitude of potential energy? So now we can say, if we talk about kinetic energy, this is 1 by 2 times of 13.6. Clear? So if we calculate, we can see this is 6 and we have 6.8 electron volt. Yes or no? Clear? So now we can see, if we calculate total energy we can calculate like this. Kinetic energy we have 6.8 minus 13.6, and this is equal to minus 6.8 electron volt. Yes or no? Clear? So now we will provide 6.8 electron volt energy. Clear? Or you can also understand like this. Listen carefully what I am saying to you. If we are providing minus 13.6 electron volt, we are actually going from 0.53 angstrom to 1.06 angstrom. Clear? And the rest we can say we are providing 13.6 electron volt. Clear? So actually we provided only this much amount of energy and we reach up to the reference point. Clear to you? So now if we want to free the electron, we can say in this situation we cannot free electron because that amount of energy that we are providing, in this situation also we are getting electron in a bounded form. Yes or no? So now we can say here we are getting value of potential energy, this one, and if we want to free electron, total energy we have to provide this is 13.6 electron volt. Clear to everyone? So this is all about this question. Clear?